time as a disinfectant. I came back to my place after being gone for a week and it still wasn't clean. Why? Well, we don't actually have the perception that just because you give a room time, it'll clean itself up. We all know if you leave dirty dishes in a sink long enough, they get gross. Mold can get really bad, not just the smell, but the health hazard as well. You've all seen pictures of bacteria growing on petri dishes, but why don't we see pictures of viruses growing on petri dishes? Because viruses cannot really grow. There's a question of whether they're even living anyways. Let's look more deeply into the structure of a virus. You can see in the middle there's some genetic material. DNA in the case of viruses like herpes, RNA in the case of the coronavirus. There's an envelope or capsule protecting the genetic material, and that's about it. If you look at a human cell, it's infinitely more complex. And there's a reason for that because it actually needs to have the capacity to produce proteins. It can reproduce itself. The virus can do none of that. It cannot do anything by itself. You cannot give it the proper nutrients and watch it grow. It simply cannot take in the nutrients. But we all know we could take in nutrients and grow from baby to a teenager to an adult. The process of creating something from DNA is called translation. First it gets converted to RNA, then the RNA gets translated into a protein. This complex that you see here is called the endoplasmic reticulum. It converts the blueprint that's called RNA into a protein, a physical structure. And if you think about DNA, RNA, it really is like a blueprint. It's wonderful to look at. You can reproduce it. It tells you an awful lot. Somebody else knows what you mean when you give them the blueprint, but it's not actually a house. You need to have construction workers before you actually get a house. Otherwise, it's just a blueprint, an idea that hasn't been translated into reality yet. Viruses need to infect cells, whatever cell they're adapted to, so they could reproduce. After they infect a cell, they use the cell's construction workers to build new virus particles. This is the only way they can reproduce. Out of cells, they have no way of reproducing. But that's not actually just it. Viruses also can't support themselves. Remember, they can't actually make anything. They're just full of genetic material and have the capacity of infecting other cells, but they cannot repair themselves. Unlike many animals that can regrow limbs, viruses are not. Even though we can't regrow limbs, we actually regenerate all the time though. Our skin regenerates. I remember when my brother scraped up his face in a biking accident, it looked horrible. But less than a month after, it was back to normal, because he was young. For all of us, our outermost layer of the skin, the epidermis, regenerates in about a month. Next month, your skin will be a different you. Many other things also regenerate and change. If you hate something right now in terms of taste, just keep on eating it for the next few months. Because by the end of 6 months, your taste buds will be completely new. But it's only because our cells have all this complicated internal machinery, so they can create new cells, they could heal themselves. Viruses, remember, have no machinery at all. They have no construction workers. They can't create anything. Remember when you wash dishes? I remember growing up with my brothers, we all had to take turns washing dishes. Remember one brother complained about the other brother because he left some plates oily. I think because he used gloves to wash so he couldn't feel the grease as well, and he liked conserving the dishwashing soap. But we all know that soap removes oil and grease. Well, soap also destroys the outer fatty layer of the coronavirus capsule. And because it has no construction workers, it can't repair it. But it's not just soap that destroys it. Anything basically destroys the shell. Remember, viruses are tiny. Even wind or a dust particle hitting its shell would damage it. And after the damage is done, after the shell is opened, the insides are exposed to the outside world, and the genetic material, which itself has no protection, will fall apart, basically. Sometimes we forget the world is a very harsh place. That's because we have regenerative ability. If a virus, you start out with one shield, a protein shield, maybe covered with a fatty layer in addition, and that's it. If you use up your protection, before you get inside a human cell to recreate yourself, you're done. Remember Jumanji? They're trying to finish the quest so they could get out of the video game back into real life. In the game, they have life bars, and when they die in the game, one bar disappears. There's no way of making the bar regenerate, and when the 3 bars are gone, they die, in the game and outside as well. Viruses are the same. They start out with a certain amount of protection offered by their capsid and envelope, and if those get destroyed, the genetic material inside gets exposed to the outside world and it falls apart. They're dead. Even if you consider them not alive anyways, now they're ineffective. They can't actually do any damage to anybody. So unlike my messy room that didn't become cleaner over time, the environment does actually become cleaner over time as more and more viruses die, particularly with regards to the coronavirus. If you leave a surface without doing anything to it long enough, the coronavirus will die. It will be ineffective. It can't actually infect anybody else. Without a means of reproduction, their defense, their capsid envelope, diminishes over time. They can't make it stronger. They can't repair it. And eventually they die, they become ineffective in their ability to infect other people. Their DNA, RNA splattered all around. Their proteins inside that were able to inject other cells are all gone. How much time does this take? Well, that's a little bit more in terms of complicated topics. We'll have to look into some numbers and we'll talk about that in the next topic.